Hello, everyone. Nice to talk here. Thanks our host to invite me to give this talk. Yeah, so today I will talk about how Wyze uses AI to scale cost-efficient video understanding. Like before the talk, I want to ask you, have anyone heard of Wyze? Oh, thank you. Yeah, so we got confusion a lot of times. Like we are not a Wyze, which is a map company, give you navigation. We are not a Wyze, who is a self-driving company. We are also not Wyze, which is a payment company, doing the fintech. So so right now I'm a scientist at Wyze, and we are working on the VLM and AI detection. Today I will cover these topics. So Wyze is actually a Seattle or client-oriented headquartered company, and we are founded at 2017. Right now we have served more than 10 million households in US, which is like 10% of all the US households. Or in another way, you can say we have sold about 20 million cameras in US. So which is kind of like a large amount for us, and this also make our work very challenging. So the biggest challenge we are facing in our work is the data volume. So every day, the videos we are processing is about 2 billion. We did some simple calculation. It's actually at the same level of Tesla FSD, same length. That makes it very challenging. And the second challenge we are facing is because we are helping like millions of households. Every house has different scenario, different camera setting. It requires our model to be very robust and provide a good quality. Of course, we can just using the most expensive model to hosting service for them. But in that way, we require a lot of GPU, and all of our money will burn out very fast. So we need to make cost-efficient models. Okay, so the approach we propose to tackle these problems is using the edge and cloud collaboration approach. Right here, we just show the architecture of our whole system doing the AI detections. So to understand this figure, we can categorize this into 4 parts. The edge path, which is the camera you will purchase, and it will be equipped with some AI chip with limited computing power. The advantage of this is it can do some simple AI detection, and it is free. But the disadvantage of this is it's just limited. The cost making it the computer power very small. The second part is in the above part, which is the cloud. On the cloud, you can just have very good models, which is able to provide very robust and higher quality detection results. But the disadvantage of that is the more data, the more requests you make, it will be more expensive. And in the bottom part is the storage. Once you have the videos or once you have the detection results, you want to store them or cache them, and you want to save it for later use. Actually here, we want to thank Momento provide some of the service here. And in the fourth part, in the right part is the UI interface. Our customer going to see that's the detection results. They will realize someone entered the home or the pet is doing something. So the workflow is like this. Your camera will catch some events based on motion or based on other signal trigger. And then it will do the first layer of analysis. For example, if just a simple nothing happened, we detect nothing and with a very high confidence score. And then we will decide, okay, this is enough. And we just send the result to our user and save the results here. We don't need to make additional call to the cloud. This will save our money. Some other times, for example, there are too many people, or the video quality we captured is within motion blur or something. The edge computing power is not enough to provide very good results. we're gonna make a call to the cloud, and the cloud model is capable of having much better results and do the calculation. Okay, so here is a more published patent. We show what exactly details we do to do the calibration. What I just mentioned is kind of like one example, like the edge will do a calculation first, and then depends on the confidence score here, and decide to call additional cloud or not. But there are more complicated calibration cases. In some other cases, we will just do edge computing first. Then we found that, okay, we need additional cloud computing to help us. But at this time, we're not just make the call to the cloud. We're going to prepare some additional features, which means on even the edge side doesn't give enough results. They will prepare some pre-computing. In this way, the burden of the cloud side will be less, and we save additional cost. Okay, so by doing this kind of collaboration of the edge and the cloud, we're making it possible to run this cost-efficient detection for our customer. So we finally successfully building this kind of like interactive loop, which is so we first have the models, and then we can serve the models to add our service. And when the new customers' videos came in, we're gonna provide the results, and the customer will see, okay, this result is good or bad. Because we have the volume is good, is large, right? We have 10 million users. Some of the customers are willing to provide more feedback. If our detection is not good, they're gonna say, okay, it's not good enough, and please make it better. And some of our customers will donate their data to us. So here's the bad cases. Hey, Wyze trying to improve it. You can use my data. A lot of the features we designed are from the community. They make this wish list. We develop it. So they are willing to provide more feedback to us, and we can accumulate the data, we can improve the model, and we can improve the service. And then once they have the better experience, they probably will find the additional drawbacks and give us. So we make it kind of like fly in a very healthy way. So this is some result we want to showcase this patent's work. When the AI detection or deep learning detection begins, we have significant gap between the SOTA or the state-of-art models. But with collecting more data, with our improvement of the model, we're able to outperform the SOTA models. And eventually, we actually applied this story to a lot of applications. We first started with the person detection, then applied to pet, face, vehicle, package, and the sound detection, including crying, mewing, gun shooting. So the right side of the figure shows some of the distributions of our volume. If you can see that the edge side takes some portion, the collaboration one also takes some portion, and then rest for the cloud, they will do the rest of it. So as a result, I think we make this work. And Wyze have a vision, which is to make great technology accessible to everyone. So this means we want to make the hardware cheap so that more users are able to get the hardware. We also want to make the software subscription cheap so that, of course, more users can use it. So as a result, with the large population, we are able to collect more data, collect more feedback to improve the service. So here, I really want to thank to our user. They are really actively donating the data to make them model better. And as a result, here we have accumulated 29 years of videos to improve our model. Here, the 29 years is not what I mentioned, the 2 billion videos we process every day. This is like So they find the bug, they find the errors, they donate. And okay, so we're free to use, or we can use this to help them get a better model. So with these resources, it comes challenging for us again. So how can we leverage this data? How can we get better model to help them? And the answer to this challenge is we want to do ALM and provide a better experience. So, I mean, right now, for all the AI companies are in the ALM era, we improve our experience from different kind of way. Right now in Wyze, we are developing the service based on these three pillars. The first, we're going to use the ALM to have better video understanding so that help the user analyze what happened and send them notification. The second part is we're going to provide some natural language-based visual search. Imagine that if you really want to know what your family, what happened in your family, I think the user way is always like looking into the events and scroll, but we make it possible that with natural language, you just search with typing. And the third one is, of course, within the sufficient data, we want to do some in-house research, and we want to benefit the user and the community. Okay, here's the video understanding-based service we want to show.
Person detected. Who in the world could that be? Your neighbor with another petition to sign? Your daughter attempting scooter stunts in a driveway? Well, what if you didn't have to wonder? A mother welcomes her daughter home and they hug on the front porch. Oh, isn't that much better? Introducing descriptive alerts powered by Wyze Intelligence. A giant herd of goats graze on the front lawn. Yikes, they were kidding. A man rides down the driveway on a hoverboard. He falls and then questions his life choices. A dog steals a package off the front porch and runs away. Bad dog. With descriptive alerts, security cameras will never be the same. A fire has started on the stove in the kitchen. Our places are so last decade. A man barges into a home swinging crutches at invasive squirrels. Go get him, Tiger. A speeding black SUV flies through the air and lands on a flower bed. Hope he had insurance.
Very okay.
Pizza has been dropped by a delivery man on the front porch. 10-second rule. A girl leaves home while a dog starts to... Oh, yeah, that one's a little too descriptive. Wise, never wonder.
Yeah. So yeah, this is basically like we leverage the understanding capability of VLM to analyze the videos and then send out a notification to our users so they really very easily know what happens based on description. So when we release to our users, we found that there's some feedback. They are not very happy. One of them is like they just keep getting repeated notification, like one car coming, maybe 3 notifications the same. So when you think about, okay, how can we make this even more efficient? Which is let's VRM to decide what content to show up. So a very straightforward pipeline is here. Like we're providing the description, and we use ARM again to analyze is this description have the similar meaning with the previous description and decide if this is a repeated one or not. Of course, we can also decide if this event is important or not, and then based on this to send out the notification. And as a result, for example, if a car passing by, we found that it's repeated, we just ignore it. But of course, we're going to save in the DB. But if it's something important, UPS come for the delivery, and then we can send out. Yeah. So once this is done, the user feels happy about it. But again, sometimes they really busy. They don't want to go through all the notifications. One thing we can do is, okay, we can do the daily summary for them. It's like summarize what happened at your home, and you just need one simple paragraph to read. And the third one, I think this concept has been discussed previously, is everyone have different preference. Everyone want to see different content. Someone like pets, someone may just like to see information about their family. So we want personalization. Because we have different user information, we have the information about their what event they review, what content they like. So we can build their user profile, and then based on that, decide what kind of content to give to them. Or even the same activity, we can describe it in the user's preference. So this is a work we do to make this experience better. Another one is search. So we make this service so that the user don't need to go through everything just mentioned, and we can just type information, type words, so that they can get results directly from the video. Yeah. I don't want to get too much technical detail, but to summarize this is we just use embedding to represent everything. The input signal can be multi-modality, right? Audio, video, image, and text. And we use embedding to represent them. And when the user types out something, we get embedding again and do the search, and then we get the results. So yeah, the results you can see, if I just type a person near a car, we show these results. And if we type in baby in yellow, we can also show the related events. And here are more results. Okay, so for this part, it's actually also very costly. How to save cost in the pipeline. We summarize the 4 components we can work on. The first is embedding as a representation instead of saving all the videos and raw information. The second one is the embedded dimension. It's more like some engineering trick to make it more compression, more compressed. And the third one is like we're gonna optimize the storage. Okay, so this is for the video search. And the third one we can do is making use of our data to make some in-house model and do some research to make the capability much better. So this is actually our starting point. We released the Smart Hole Bench, which is we labeled a lot of events. And we provide the labels. We try out with different VMs. We report the results here. There are about 1,000 of video in this benchmark, and we are able to show the different capability of all the existing either open source or closed source models. Okay, so yeah, so this is what is we are doing for the LLM part. I think that summarizes most of my work, and for the next step, what we are working on, including this path, we will try to make VM again affordable to our user, because to be honest, the feature I just mentioned, especially for the VM, they are very expensive. And in order to make our user able to use that, we're gonna develop more efficient but good performance model based on the data, based on a lot of other like compression optimization tricks. And then we're gonna bring more exciting cameras, and so that our user can have the hardware, have the interface to use our service. Yeah, the final is with the help of our VR model, we're gonna make the experience much better again. And finally, we are working on in-house research to contribute more to the community. Yeah, I think that's all. Thank you.